Welcome. And then we promised in our previous video, if you haven't watched that video, we advise you to go check that video because some of the formula we are going to use in this video are or were proven in the previous one. This is a Wassce question. It says the period of rotation of planet Earth is 24 hours. So we will first start with that. The period equals to 24 hours. So what we are going to do is we're going to change these hours into the seconds, which means 24 hours. Each hour is 60 minutes, and then each minute is also 60 seconds. If you multiply 24 by 60, that is going to give you 86400 seconds. So when you do that, now we have this as the revolutionary period or the rotation period of rotation of planet Earth. Now we come back to the question. It says calculate the distance of a satellite above the Earth's surface when it is put in a parking orbit. We assume this is the planet Earth with mass located at the center and radius r. You say the radius according to the question is 6,400 kilometers. That's the question. It says radius of planet Earth is 6,400 kilometers. Now we assume there is a satellite located here, and that is its parking orbit. So the distance from the surface of this satellite to the planet is what we are asked to find. We call it h. So, but what we are first going to do is we find the distance from the center of the planet Earth to the satellite. We call that little r. Then when we know that, we subtract it from big R. Now, from our previous session, we said that the velocity of a satellite is given as square root of g multiplied by r, where r is the distance from the center of the planet to the satellite. But also, since the satellite is said to be on its parking orbit, we can also say the velocity is equals to 2 pi r all over t. So what we are going to do is we equate these two, that is v equals to gr and v equals to 2 pi r over t. So we're going to say root of gr equals to 2 pi r all over t. So we check if the information we have in the question is rich enough for us to solve the problem. We are given the gravity we are given acceleration due to gravity, and we are told it is 0.23 Newton per kilogram. We are also given the value of the period of rotation of the Earth, and that is given as 24 hours. We already converted that to seconds, and then we are also given the value of pi. So in that essence, the only thing that we don't know is r. So what we do is we try to make r the subject of the formula first, then we substitute directly so it can make things easier for us. What is the first step? The first step is you look through this and then you square both sides of this expression. When you square both sides, you're going to have g times r is equal to 2 squared is 4. Then you have pi squared r squared all over t squared. So when we have this, the next thing we do is we try to make r the subject. When we cross multiply, we are going to have gr multiplied by t squared is equals to 4 pi squared. Remember, I said pi squared, and then I will have r squared. First, what I want to do is I want to make r the subject. There is r here, and there is r there. So I'll divide both sides by r, of course, to eliminate this r here, and then this one will reduce. Also, I'll divide both sides by 4 pi squared, divide by 4 pi squared. And then now what I am going to be left with r, and a direct substitution, is going to be equals to g multiplied by t squared all over 4 pi squared. So that's what we have. R equals to g times t squared over 4 pi squared. With all these variables given, so we have r equals to, what is g? G is given by 0.23. what is T? We already converted that. That is going to be 86400. And then this one has to be squared, divided by 4, multiplied by, we were given pi in the beginning and we were told that pi is 3.14. We have multiplied by 3.14 whole squared. So if you do that, you point the numerator, which is 0.23 times 86400 squared. You can pause the video and then punch it to see what value you have. So that is going to give you, if you punch that, that is, you take your calculator and punch what? 0.23 times, you take that, 86,400 squared. So that is going to give you a very large value, which is, I'm going to write the whole thing, which is 1716940,800, divided by, then you come to the denominator 4 times, use the pi that is given, 3.14 squared, and that is going to be 39.4384. So now finally we will have R. For now we will be 1716940,800 divided by, this is the last answer that you point, so you can just put answer, and then that will give you R as 43534,747.86. That is going to be 43,534,747.86 meters. Remember, from the diagram here, if we want to get H, we will say H equals to R minus the radius of the Earth. So we say the height above the surface will be this value, 43,534,747.86 minus. So we have the radius of the Earth is given in kilometers. That is 6,400 kilometers, which is the same thing as 6,400,000 meters. So you take that, you take now this value minus 6,400,000 meters. So if you do that now, it will give you the height above the surface will be equals to 37,134,747.86. We have that in meters, which we can write in standard form as 3.71. We put that into standard form, then we have times 10. What will be the power? You look, this is 1, 2, 3, 4, 5, 6, 7 times 10 to the power 7 meters. Thanks for watching that video, and we will see you for more videos coming our way. Remember to subscribe our channel so you can have as many of such interesting videos. Thank you.